And I am going to stop my video just because it makes the recording work a little better. So, all right. So today we're going to be talking about Skimmer Basin Design. This is going to be, if you've joined us before, it's going to be a similar format to what we've done the past couple of months, but we've got a focus today on Texas, Louisiana, and Alabama requirements. Now, majority of the information will apply in most locations, but we are going to focus on those three states to give a little different flavor today. So a little bit about me. I'm a 1992 grad of Clemson. I have a BS in civil engineering. Founded CCAT Engineering in 1999 and owned it until 2018. I invented the Marley float skimmer in 2013. I'm a licensed professional engineer, South Carolina, North Carolina, and Georgia. So in short, for those of you that are consultants here, I spent most of my career doing land development, design and permitting and development related engineering. So today we're going to talk about introduction to skimmers and floating outlets. I know for those that have been able to join from Texas and Louisiana and somewhat in Alabama, they're not quite as common yet. They're kind of coming. So we're just going to give you the basics. We're going to go over what the design requirements are in those states, and they do vary a little bit from some other areas. And then we're going to kind of pivot and we're going to talk about using skimmers for post-construction, how to do advanced skimmer modeling in hydroflow. And then also we're going to finish up talking about the Rymar water quality filter and a filtration-based design for post-construction water quality. And then if we have time, we're going to touch on the digital Sightbox service, which is a new service that Rymar is also working with. So just for those of you that are familiar with ponds, it used to be we used a perforated riser, often had a hole at the bottom of the pond, or maybe it had several holes, but it ended up pulling water in from the bottom of the pond where we're trying to get all the sediment to settle to. So it's pulling from where the sediment is highest. So real quick here, do have a couple of polls in here today. So like to just know how familiar you are with skimmers. So just if you could answer that, just give me an idea if they're new, got somewhat, or if you used them a lot. So. All right, looks like, you know, about 13%, I'm gonna end this now and share it. About 13% are new, 60% are somewhat, but need to learn more, which I appreciate you joining us today for both of those groups. And for those of you, about 27% have used them on projects. I appreciate that. Hopefully will consider the Marley float going forward. Oops, there we go. All right. So for those that are not familiar or, it's relatively new, skimmers are designed to take water from the surface. So most construction general permits now have a surface withdrawal requirement for sediment basins. So skimmers are the most common way to meet that. The Marley float skimmer is a little bit different. We take water from just below the surface. We've got this debris guard that sits down in the water about 12, 14 inches, and water comes into the skimmer in that 2 to 6 inch depth below the surface. There are a variety of skimmers out there. The Faircloth skimmer is probably the most common. Mr. Faircloth invented his about 25 years ago or so. The Erosion Supply Company is similar to the Faircloth. Got the Marley float, looks a little bit different than the others. And also the IES is a little simpler design. There may be some others out there, and I know some contractors occasionally make their own, but those are the most common ones we see. So really the basics of sediment basin design, there's just three basics. Number one is the basin volume. So depending on where you're located, the basin volume is going to be specified by your state or MS4. What we generally see are 1,800 to 3,600 cubic feet per acre flow into the basin. Some areas also require basins to have a permanent pool or sediment storage that is not drained by the skimmer. Main point here is use that required volume when you're sizing your skimmer, not the actual volume to the size of the skimmer. That's especially important if your basin's a multi-purpose basin and it's going to become your detention pond post-construction because it's likely much larger than the required volume of the basin. So number two is going to be dewatering time. Most states specify a dewatering time that they want to see. Generally, what we see is the minimum is around 2 days. Some states a little bit less than that. The maximum is typically around 5 days. Some states go out to 7. But generally, that 2 to 5 days is a good range of what we typically see for most state requirements. And then number three is simply flow rate. And so once you know your volume and your dewatering time, then you can establish that flow rate. We recommend you use a range of flow rate when you're specifying your skimmer basins. What that does is establish a range of discharge rates and drain times, so that if a contractor wants to use a different skimmer, it's a little bit easier for them if they got one left over from another job. It's hard to hit a specific flow rate necessarily. They don't always match, but if you got a range set, based on that 2 to 5 day or whatever the range is allowable in your state, makes it easier for them to do. So again, we're going to have one more quick poll here just to help me out, just to know where you are located. So we are focusing today on Texas, Louisiana, and Alabama. And we know we're going to have a lot of other folks on. Just curious how many from those states we're able to get with us today. All right, we're going to end that, share it. So we got a couple of people from Texas and a couple from Alabama, majority from elsewhere. So we appreciate everyone that's joining, and thanks for the Texas and Alabama folks who are able to get on today. So we'll run through requirements for the three states we're focusing on. So we'll start with Texas. So the Texas CGP requires sediment basins for drainage areas of 10 acres or more. And it requires outlet structures that withdraw water from the surface. So for the volume for Texas is based either on a 2-year, 24-hour storm, or if that's not available, you can't calculate it for some reason, a minimum of 3,600 cubic feet of storage per acre drain. And like I said, unless infeasible when discharging sediment basins, utilize outlet structures that withdraw from the surface. That infeasible may apply maybe if you've got frozen conditions or some really strange configuration of your pond, but most of the time, the MS4 is looking to meet that surface draw requirement. So the sediment basins or skimmers are relatively new in Texas. The North Central NCTOG, this North Central Texas, I forget the other name of it, provides technical guidance on stormwater requirements. They have a manual called the iSwim Technical Manual, and in there provides standards for sediment basins. You'll notice that their standard detail doesn't show a skimmer. However, the Texas Construction General Permit does require surface withdrawal, and that's been in place for a little over 10 years, but we're starting to see that enforced more and more throughout the state of Texas. It also provides sediment basin details, as well as everything else required for the sediment basin, and really everything else for your construction site. But as we're focused on basins today, the iSwim Technical Manual is the best resource I've found so far in Texas. Now, there are several MS4s, cities, counties that have their own design guidance. I know Austin has started doing more with that as well, and some other areas. So depending on the area you're working in, we recommend you touch base with your local MS4 permitting agency to make sure what their current requirements are. Real quickly on Louisiana. Louisiana CGP was adopted in October of 2019 to regulate large construction activities in Louisiana. That's 5+ acres. They have another construction general permit for less than 5 acres. It's a little bit newer than this one. They do say that the storage is calculated based on a 2-year, 24-hour storm event, or that 3,600 cubic feet of storage per acre. And it is required for 10 acres. I'm not sure why that's blacked out, but 10 acres or more requires that. If they have basins serving less than 10 acres, they still do require that same storage for that. I also found this manual. It's the Urban Stormwater Runoff, provides best management practices for coastal Louisiana. Within it, it also provides some guidance for sediment basins within it. So honestly, pretty limited information that I was able to find. And I didn't see anybody from Louisiana on today, so I'm not sure I can get any help with that. But if you have other information that you can send to us, we're trying to compile, make sure we're accurate on what those are. And then finally here, Alabama. Alabama's got what they call the Blue Book. It's the erosion control, sediment control, and stormwater management on construction sites and urban areas. There are 2 volumes. There's volume 1, which has kind of the design criteria, best management practices for it, or developing plans. And then volume 2 talks about installation, maintenance, and inspection. So you really, when you're going through designing, you need to look at both of these. They're similar, but have a little bit of information in each one. So the Blue Book provides guidance on sediment basin design. It goes through all the key criteria and goes through the details of that. It also provides information on skimmers for the sediment basins. And it does specify the dewatering rate of 48 to 120 hours or 2 to 5 days for Alabama. And this is their design criteria for temporary sediment traps, which really also applies to sediment basins. For sediment traps, is recommended 10 acres as a maximum. I think sediment basins can go a little bigger than that. Again, the 3,600 cubic feet per acre is the minimum volume, dewatering time of 2 to 5 days, and they want a skimmer or other approved basin dewatering device to meet that surface withdrawal requirement. One thing to point out is the Marley float skimmer is approved by Alabama DOT. Got approved back in 2015, and so we're still on their QPL for DOT for that now. So quick summary here. This is just a little table that shows the different standards. So basin volume, all 3 of these states use that 2-year 24-hour storm or 3,600 cubic feet per acre minimum. Texas, Louisiana don't specify a surface area. Alabama does, 325 square feet per CFS of the 10-year storm. Principal spillway, that'd be your skimmer and riser. So either the 2-year or 10-year storm. And emergency spillway is either a 25 or 100-year storm. So the emergency spillway incorporates that overflow spillway. Texas says 10 acres or greater. Louisiana's 5 acres or more. Alabama says when necessary, if you can't meet it with other means, silt fence or other BMPs. And then dewatering time, Texas, what we found was 36 to 72 hours. Louisiana wants it to drain within 48 hours, which is a little quicker than most states, but that's what the state requirements show. Then Alabama, 2 to 5 days. And it just always note that local MS4s may have slightly different requirements, especially in Texas and Alabama, where these requirements are just kind of getting in place now. So, what we're seeing is the cities and counties are figuring out what works best in their area.
Jenny, I'm sorry to interrupt at this
Sure.
point. I'm in Georgia, and here I deal with about 12 county region, which is called CSRA. None of the things that you described apply here because the sites here are within 1 to 2 acres. And detention ponds are the only one there. Nobody has even attempted to put a skimmer there to do this, remove the turbidity or the sediments from the basins, and the basins are not maintained as well as they should be. And the county people don't even bother to impose their will for dewatering or maintaining the ponds. What do you say about where the area is only 1 to 2 acres? Because I deal with gas stations, motels, and things like that.
Right. So what we've seen, Georgia also has the Green Book for the sediment erosion control manual. Georgia doesn't technically require the skimmers to be installed. They do still allow perforated risers. However, what we see in most of the MS4s, especially where a lot of development, maybe around Atlanta and some of the bigger cities, they're typically looking to include a skimmer. But there are definitely some areas that leave it up to the engineer. Based on our experience and just how beneficial the skimmers have been shown to be in increasing the sediment trapping efficiency. Obviously, we would recommend that, but if your local area is leaving it up to the engineer, We just say, go with whatever you feel is best for your site in that location. Although I do know, Georgia also typically has turbidity sampling requirements, and a lot of times it can be harder to meet those. Skimmers don't do a lot for turbidity. They help some, but typically you're going to be looking at some sort of flocculence or something, depending on your soil type, to meet those requirements. But really Georgia's still does allow it to just up to the engineer's discretion as far as what they use. So.
Engineers don't specify at all uh, these skimmers or any means to reduce the turbidity or the flow rate or even the stormwater management people here do not ask for it.
Yeah,
Even
I
they,
mean,
when they approve the plans, they don't even mention that when the add skimmer or control turbidity or this and that.
yeah, again, that every MS4 is a little different on their level of enforcement, right? I mean, there's some that let you get away with a lot, and there's some that are extremely picky. So, I think us as consulting engineers, we try to, make sure we're doing what we need to do to meet requirements. And, if others do different, then, that's kind of on them. But you know, I would say always kind of err on the side of doing what works best. So.
Okay, thank you.
Yep. So here, the one thing we like to point out, skimmers have always been assumed to be constant head, constant flow devices. This is a table that was done by TRI Environmental when they actually did a study for Georgia when they were updating their green book. And it's three different skimmers. There's three different 3-inch skimmers in this case. And just like to point out here, two of the skimmers are pretty similar in flow. Like here at 1 foot of depth, they're right around 37 GPM. One's at 70, so about double. All three of the skimmers experienced about a 25% increase in flow rate from 1 to 4 feet. And again, two are similar and one's again nearly double. The main point here is if you simply specify a 3-inch skimmer without any other detail, you're not really sure what flow rate you're getting. So we really focus on making sure that flow rate or drain time and volume are on the plans to make sure that you've got it accurate there and the contractor installs a skimmer that meets the requirements. So we have a design tool, or actually have a couple design tools on our website. We now just have what we call our engineers pack, which you can download to get all of our information. This tool includes a permanent pool, which you are required to do in some areas, but not all. But we also have one that doesn't have the permanent pool. So a couple things to point out on our tool. One, we have this little checkbox up here. So the idea here is that your required sediment storage in some areas, what is typical is 1,000 cubic feet per disturbed acre. And then the required dewatering volume is typically on the total drainage acres going. You can adjust these to the numbers that you see fit, like in Texas, Alabama, Louisiana, it'd be 3,600 cubic feet per acre. But that gives you a check for the required dewatering volume. And then in here, you've got your minimum and maximum time to drain. Most states, that's going to be 48 to 120. Pond depth, now that depth is not going to be your total depth. It's going to be the depth required to meet your calculated, your required dewatering volume. And then you got a top length and width and a bottom length and width. We definitely recognize there's very few square or rectangular basins. And so just use your engineering judgment to adjust these numbers to the calculated pond volume. We try to get within about 5% of the required dewatering volume. And again, we're typically trying to hit a range of 2 to 5 days or so. So, an extra couple hundred cubic feet or a few less 100 cubic feet is not going to make a big difference in the skimmer. When you finish that up, we've got a skimmer report page tab down at the bottom. The sheet calculates the drain time for each one of our skimmers with each orifice configuration. When you go to the report page, it's going to have a nice, neat 8.5 by 11. The top's going to be all your information where you specified, the site requirements. It's going to calculate the minimum average flow rate and the maximum average flow rate based on the maximum time and minimum time to drain. And then because it is our tool, it's going to tell you the drawdown time for every one of our skimmers and tell you which one of ours meet the drainage time that you specified. We typically say shoot for that right around 3-day drain time. I like, kind of between 2 to 3 days in most cases. Again, depending on what your MS4 requires, you want to make sure you meet that. but that's typically kind of what we see. We also, when you download that pack, we have multiple basin details. And so the basin details, this one is for a wet basin with a permanent riser structure. We have them for a dry basin with a permanent riser. We also have wet and dry basins that are just temporary, just have a pipe through the dam and a spillway. This chart is going to give you the design criteria for all the basins on the site. So edit that as needed for your location. And right here is where you're going to set your minimum and maximum dewatering times. And then down here is going to be the information specific to each basin. So it'll be drainage area, going to a disturbed area, the flow rate for either your 2 or 10-year storm, whichever one's required in your area, the basin volume. Again, you want to make sure that your required is at least, I mean, you're provided it at least meets the required surface area if requirements are that. And then here's just your outlet information. So your outlet invert, pipe size, emergency spillway width, skimmer size, orifice diameter. And here you can specify the skimmer manufacturer. That'd be Rymar or Marley in our case. Is an equal allowed, yes or no? And we recognize typically that would be yes. There may be some situations where you say no. And then a skimmer flow rate. So you'll have your minimum and maximum flow rate specified here based on your minimum and maximum time. By doing that, when you submit this for review, the reviewer will have confirmed that that range works. And so if your contractor comes to you and says, hey, I got this skimmer left over from this other job, will it work for this job? You can quickly say, well, what size is it? What's the flow rate? You know, does it fall within that range? Okay, great, it works. Or no, sorry, it doesn't work. So we also have our skimmer details. A couple of things to point out about it. All of our skimmers come with this orifice plate with standard sizes. So some other skimmers out there have a disc that you cut to like 1/10 of an inch or so. We don't do that. We kind of decided that it would be, you know, easier for the contractors, I guess, to provide standard orifice sizes. Our detail provides the flow rate for each one of those. One other thing to point out, we get asked a lot, what is the length of this pipe need to be? We typically say about 1.4 times the height of the riser. That allows the pipe to come up at basically a 45-degree angle, you know, for the skimmer to sit in the pond. We provide a flexible coupling. So the only thing the contractor needs to provide is the pipe between the coupling and the skimmer. And typically the riser structure already has a stub out in place. Now, a couple of pictures here about installation. This is one I like to point out. It's actually a pretty good picture. You got, you know, the contractor tracked in the sides. He's got his baffles in, got his skimmer in, got his stone pad in, everything that's typical on a basin. However, one thing I like to point out, this stone here was put in after the pond was graded. And so all this looks like to be a dry basin. It's never going to be dry, completely dry, unless it just evaporates or infiltrates. So typically we would recommend depressing that area a little bit to try to drain as much of the basin as possible through the skimmer. We've seen some really bad installs. We try to do what we can with stickers and labeling and such to help installations, but this one, you know, there's no flexible coupling. The pipe looks to be about 1 foot long. You look close, the valve on this side's open. So skimmer's really not doing hardly anything on this pond, but you know, sometimes contractors do contractor things and don't install them correctly, although we are seeing less and less of that. We've seen some of ours installed upside down. We actually have put a, a sticker on them to say, hey, right side up, and now provided a QR code to an installation video. You know, this one, the pipe length is not near long enough. Just lots of things that was just not done correctly on this design. And then last thing, skimmers are not maintenance free. You know, this one has a vegetation actually growing out of it. This was a site that I was the engineer on several years back, and they used a different type skimmer, but it had about a 9-inch root ball within the skimmer that was with, you know, not letting the pond drain properly. So we're going to pivot now, talk about permanent use of skimmers. So we're going to do one more quick poll here and just say, have you ever considered using a skimmer for permanent use? So if you would, Mostly no's, got one yes, which is great, and a couple of considered. Um, I got two yeses, that's good. We're going to end that. Only had about half people input it, but you know, most people say no, which is pretty common. But now we've got about 20% that have said yes, they've at least considered it, and 2% that said they've done it. So that's awesome. So you know, when we do a typical dry detention basin, and I would say, the skimmers probably, well, they'll be helpful for wet or dry basins for sure, but especially for dry basins. You're removing the skimmer, you're putting in some sort of low flow orifice to release that first flush for water quality, and then you got some sort of guard or filter to try to prevent clogging, right? But all of our um, water quality is based on settling for dry basins. What we're trying to do is we're trying to get all the pollutants down to the bottom of the pond, and then we're releasing the flow from the bottom of the pond. So maybe there's a better way to do that. So, again, the basins rely upon the natural settling of sediment particles as they travel, from the inlet to the outlet. And your skimmer is going to release that cleaner water from the surface. They're obviously widely accepted for construction and have proven to be very cost effective. So, would it make sense to use the same methods for post-construction to help achieve our water quality? So this is one example where we put in a skimmer really for maintenance. So this was a basin that had not been maintained in a very long time. You can see it's holding a lot of water and got tons of trash in it. Um, we got approval to to retrofit it. And we put in a skimmer. And this last picture is actually the best one to show you. So you've got these are the old orifices here. We put in new orifices here, redesigned this pond. Um, the backstory, this pond had not been maintained in probably 20 years, and there's a 2-inch orifice 6 feet below the now bottom of the pond. And so we were able to redesign the pond, put in the skimmer to help with that maintenance, knowing this pond received just an enormous amount of trash and debris. About a year later, the then owner was starting to maintain the pond. Landscapers went out that day and cut it, let all the debris go down to the bottom. Before they could get it out, they had a 5-inch rain, and so it washed all the debris down to the outlet. But you can see our skimmer still sitting there, did not clog. It was able to drain the pond. If you had a 2-inch outlet here, we would have had a very high likelihood it would have clogged. And if you look at this, that depth is about 8 feet from the skimmer outlet to the orifices there. So it'd have been a pretty dangerous situation to try to get in there and get that unclogged. So if you're going to use skimmers post-construction, we've got to know how to model the skimmer, in our model to show that we still meet our pre versus post conditions. So I think most of you probably use HydroFlow now that it's part of Civil 3D. So we're going to go through an example with HydroFlow. But if you use other software, good chance we've got some tutorials on our website about that. So in this case, we've got a pre-development site here, and then our post-development model here. So sample site is about 5.5 acres. We've got about 3.4 acres that's undisturbed. We got 2.25 is being developed into or being disturbed. Got a sediment basin here. And then in this case, even though it's during construction, the municipality is requiring quantity control during construction. And we're releasing this to a little side road and water's flowing across the road. So we didn't want to increase flow then. So our pre-development, our area is about 5.5 acres, curve number of 59, time of concentration just under 20 minutes. Post-development for the undisturbed portion stayed the same. For the disturbed portion was 2.25 acres. We used a curve number of 86 for during construction bare earth condition, time of concentration down to 7 minutes. So one of the main things you want to do here when you're building your basins, or typically we're putting in stage storage or stage contour area. So you're going to build in a stage so you have a place to input the skimmer flow later. So in this case, I've done 0.1, 0.3, 0.5, and then a 1/2 foot up to 4 feet. That correlates with our details, and we provide the flow rate at each one of those levels for you. So then you're going to go in and build your outlet structure. So in this case, your riser A is going to be an 18-inch pipe going out. In this case, we've got an orifice C here. That's a 6-inch orifice that's 1.75 feet above the bottom of the pond. And then we've got our riser structure. It's 3.6 feet tall, and it's got a 1 foot wide rectangular weir at the top of it at 0.6 foot depth. And then the main thing here is this user-defined column. So this is where you plug in your flow rate for your skimmer, and that will build in that flow rate curve so HydroFlow models it correctly. In the case, if your basin is more than 4 feet deep, you've got a couple of different options. Number one, you can just kind of hold that 4 foot flow rate, because in most cases, the flow rate's kind of balanced out or pretty close to balanced out by then. You can extrapolate it based on the last 3 data points. Or if you really want to dive into it, go back to our tool and put in your total pond depth. And then our tool will break down the flow into 20 increments. And so then you can just look at the flow at each increment and come over and look at the skimmer flow rate. This is just the 1/2 inch orifice. It doesn't change much. But if you go on out to the 6 or 8 inch skimmers, it does show pretty good change between 0 and whatever depth your pond is. And so you can just build that into your model and do it that way, and that will help you build in your flow rate.
Jamie, the question is that where and how you are measuring the depth of the pond? Is that at the base where the skimmer is, or it
Yeah,
is at the base?
you would start at the invert of the skimmer would be your bottom in this case, and then going up. If you've got a wet pond, obviously that flow is not getting discharged. So yeah, your 0 elevation would be at the invert of the skimmer, and then it would go on up. And then if you do have a deeper pond and you want to use this method, then whenever you build your pond, you want to kind of put in an increment that's close to these same increment levels. So it can get a little
Invert
more
elevation of
complex there.
the skimmer, invert elevation of the skimmer will be the 0 elevation.
Correct. Correct.
Okay.
Or yeah, maybe it's a whatever the actual elevation is, but your stage would be 0.
Okay. Thank
Yep.
you.
So yeah, your skimmer, like in this case, this is a dry basin, so it's the bottom. Um, oops, let me go back there. So we've got a schematic here. So we've got our 6-inch orifice, we've got our rectangular weir, top of the riser. Normally there'd be a low flow orifice here. In this case, there's not, because we're using that user-defined flow. But then if you go to your stage discharge hydrograph, it's showing this is your skimmer flow rate here. So, and if you look
Yeah,
at closer, that green line shows up. That's the skimmer flow. So pretty small percentage of your total flow.
correct.
And then if you look at, HydroFlow will give you a table. The total outflow will match that user-defined flow up until your next orifice kicks in there. So we've developed a training series. I know we'll go pretty fast in these webinars, trying to keep everybody's time and consideration. We've got 8 parts. I'm missing one part. I'm missing part 6, which is HydroCAD. I'll put that up here soon. But we go through more detail, and these are all maybe 5 to 15-minute segments. So, if you have a question on a specific part we're covering today, or like I'm not covering SEDCAD today, if you need SEDCAD in your area, all those are on our website and our YouTube channel now to refer to. So then
May I
we're going to,
recommend something, Jamie, that the
sure.
students can contact the local or the state people for this part, the people who actually not monitor who approve the plans for these developments should be able to do the hydraulics properly, so they can advise the contractor or the owner about these devices.
Yep. So we actually reach out to MS4s on a regular basis, and I'm sure we probably have a couple of regulatory folks on today. And we go to a lot of the state conferences and stuff, and even speak there about those, and try to make people aware of how we recommend to do that. So last thing we'll get into is advanced skimmer modeling for a filtration-based water quality. So go back to that original pond we showed. So we've been doing research and development on an idea to add filtration around our skimmer for about 5 years now. So this is the version we've come up with. It's a two-stage. Um, you can see here, this kind of hard to see, but this has basically a polyethylene screen. It's basically a turbidity barrier, only hangs down about 3 feet, but about 2 feet of width is the polyethylene screen to let water through. And then the interior is a non-woven material. We use a material called adsorbate. It's actually 2 layers, and they have is slit, so it's got basically panels 6 inches wide that are offset. And what that does is allows water to either flow through the fabric or kind of weave through the fabric to create some contact time. The adsorbate is really good at absorbing hydrocarbons, helps with TSS, obviously, also can help some with metals. And we're looking into potential for other pollutants like phosphorus, nitrogen, those kind of things. But a lot of those take some contact time and maybe even some chemical to take them out. So we've been doing this, like I said, for several years. Um, we After about 2 years of this one in the pond, we had a time-lapse camera. We're monitoring this. We could tell it was getting less turbidity, around the skimmer. And then at the outlet, this is the actual outlet here on the right of flow coming out of the pond. You know, I wouldn't drink it, but it's pretty clean water for a detention pond coming out of there. And so we went to the next step, and we had TRI do third-party testing and did that to an ASTM standard and showed that we get over 90% TSS removal with this configuration of skimmer and filter. About our testing, I said TRI did it. We tested 2 different versions of the skimmer, had drastically different flow rates between them. When we set up the test tank, you can see this picture on the right side of the picture, the inflow, that's the sediment laden water. It's got sediment mixed into it according to the ASTM guidelines for sediment load. And that's being introduced within about a foot and a half of our outer filter. The reason we did that is we wanted to negate the benefit of the forebay and the travel distance that you'd have in your typical pond and see just what the filter by itself basically could do along with the skimmer and the surface withdrawal. It was set up to minimize a dry pond. And it was run in accordance with ASTM has a relatively new standard, C1746 for sediment retention devices. And so all the testing was done per that ASTM standard. We have now developed our commercial version, which we're starting to sell of this. We've put that version into this pond. This is, again, that same kind of nasty pond that we've been talking about. And this is what it looks like. So again, the black fabric on the outside is a polyethylene. It's a Mirfi 402, and the interior is that absorbent fabric. And this is our current skimmer model here. In this case, we took off the debris guard on the inside. You could leave it on, provide a little more, debris guard kind of there, but typically with the outer ones, you really don't need it as much. So I want to talk about benefits to filtration versus settlement. So one of the benefits is that the peak rate of discharge can be based on your filter treatment flow rate up to the first quantity storm event or whatever storm event can be handled by the filter. So the filter is going to treat 100% of runoff from storms up to the peak rate of the filter. The reason that's important, most of our storms our water quality is based on a first flush concept. And that first flush event, depending on the volume required, which is typically an inch to an inch and a half in most areas, that can be a 1.5 to maybe 2.5 inch storm. Well, we get a lot of storms that are a 1/4 inch, right, or a 1/2 inch, and they end up flowing in and flowing out of the pond. So there's very little ponding, so there's very little treatment. But if you're using a filter, the small events go through the filter to be discharged. So you're treating that water more effectively. Then your filtration media can be customized to target specific pollutants of concern. So like I said, we incorporated the adsorbent material. It does a great job with TSS, has the added benefit of really doing a good job with hydrocarbons. So you're getting an additional treatment benefit that is hard to get when you're using that first flush volume because, the hydrocarbons are floating and those floaters are getting out of the basin. So good idea to use filters. But if we combine skimmers with filtration, now the skimmer can be sized to control the peak rate for that lower storm event. So in most cases, what we see is that 2-year storm is the lowest quantity control event. So in many, depending on the size of your site, you can size the skimmer to control up to that 2-year storm. The skimmer is going to increase the filter efficiency because you're getting that surface withdrawal. So you're trying to filter water that's a little bit cleaner than water that's just coming off the bottom. And then the skimmer is going to make it a little easier to get access to pull it over or get to it to change the filter and for maintenance. It's not a perfect solution. There are some challenges. So number one, filters are prone to clog over time, and they will require some maintenance and periodic cleaning or changing. Based on our studies so far, we're recommending a 2-year time frame to change out the filters. Um, the skimmer's got to be durable and last. So, you know, a lot of the skimmers out there are not going to be very UV resistant. The Marley Float's an HDPE product, a polyethylene product, so it's going to have a 20+ year life, which is, you know, we intended it to be used permanently when we invented it. Biggest challenge, and for the regulatory folks that are on here, there are no established standards for basis of design when you combine a pond and a filter, at least not that I've found. Some places have requirements for what they call mechanical treatment device or proprietary device, or however they have them labeled, which can be applied. But when you put those together with a pond, it can be kind of hard to show you're meeting everything. However, with our testing of 90% TSS by itself, we are confident that, you know, that with the pond is going to meet your TSS requirements at pretty much anywhere. You know, I think the highest requirements I've seen are 85%. So we exceed that. So we're going to go through a little quick model to show kind of what the would look like doing a first flush model and releasing that first flush volume over 24 to 48 hours versus a filtration based on the flow of the filter. So we're going to look at a sample site. Let's call it 5 acres. Assume it's fully wooded with a curve number of 55, and we're going to a curve number 92. So the first thing we're going to do is we're going to calculate our pre-development flow rates. And so we assumed a time of concentration of 48 minutes for our 5-acre site and came up with a 0.72 flow rate for 2-year storm, 3 for the 10-year, 5.4, and 100. Really going to focus on the 2-year storm. 10-year storm and up, you know, that's going to be managed by the rest of your outlet structure. Next thing we're going to do is look at our water quality volume and our post-development flow rates. So now we've got our same 5-acre site. We're going to assume a 10-minute time of concentration, but also we need to figure out what is our water quality storm event. And so I base this off a 1-inch runoff. That is going to vary by state. Okay, so if we do see 1 inch as a fairly common standard, so I think it's a good example. But you know, some states may be 1.5. Some states, I know Texas, in some areas it can be a little lower. It's based on the percentage impervious area. But anyway, so in this case, we've got an 18,150 cubic feet of volume that's equals to 1 inch off of our 5 acres. So we're using trial and error in our software. We came up with a 1.73 inch 24-hour storm to approximate that water quality volume. So that's got a 7.23 CFS flow rate for that event. And then our 2-year jumped all the way up to 19.72, so a 19 CFS increase. So what we see in most areas, engineers, when they're calculating that first flush, they will use a spreadsheet similar to this. So you've got your contributing area. You want to know what your volume required is. Sometimes it's reduced for wet ponds. So in South Carolina specifically, it's a 1/2 inch for wet ponds, 1 inch for dry. We're going to assume we're trying to use a dry pond as we see those are most common. 24 hours is how long we have to drain that. And so we want to see what average flow rate is required. Now, one thing about this that, you know, is really not matching to what reality is. Oops. Sorry, go back. Is that volume is assumed to instantaneously appear in the pond, right? So we're saying, poof, you know, the full 1 inch runoff magically shows up in the pond, and then we drain that volume over 24 hours is how we come up with this sizing. Obviously, that's not the case. Obviously, it comes in over time and goes out over time, but that's how we come up with this. So in this case, we said a 2.6 inch orifice would drain that volume in 24 hours. Sometimes I have less faith in contractors than maybe I should, but I said, let's use a 3-inch orifice and see how that goes, because that's a little easier to make and put in. So we designed this pond with a 3-inch orifice. We'd have some kind of trash guard there with it. We had another 3-inch orifice 3 feet above the bottom of the pond, controlling our 2-year storm. Then an 8-inch orifice, another 2 feet, controlling 10-year, and then the 100 years being controlled by the riser. When we do this, again, that 18,150 cubic feet, that takes approximately 3 feet in a hypothetical pond here. And so we can't put any orifices in below that typically. So our water quality flow is going to be a 0.25 CFS. It's only using 10,672 cubic feet of volume. So remember, we got 18,000 cubic feet of volume required. We're using, just over half of that in reality to manage that water quality storm event. And our 2-year storm outflows at 0.81 CFS. So remember, for our pre was 0.72, so we got a slight increase, but we're detaining our 10-year and 25-year. So if you look at our analysis, our pre versus post and pond, so pre really looking at pond, so our water quality event was almost generating no runoff. Now it's a 0.25, 2 years 0.81, 10 years got a 0.25 decrease, 25 years got almost a 1 CFS decrease, and then 100 years got an increase. And this is the storage required for each event. So now if we look at the option of, let's go with a skimmer with a filter design for that, our pre-development rate is a 2-year storm. So let's try to find a skimmer with close to a 0.72 CFS. So our 6-inch skimmer with a 6-inch orifice has a peak flow rate of 0.78 CFS. Now that's at a 4-foot depth. And so we're not going to use all that depth. So we're going to start with modeling that in our hydroflow. We also have details of our filter. So the thing about the filter is it is sized to keep up with the max flow of the skimmer. So the intent here is the filter will never be the flow control. It'll always be the skimmer. The filter is sized to keep up with it. Some of the 6, 8-inch, and 8-inch max filters, the the L1s and L2s will be different. We have to maintain ratio of square feet of filter to the flow rate and linear feet of filter to the flow rate. One thing to point out is the filters are generally 3 feet deep in the pond and they're open on the bottom. So, that top 3 feet of water, anything from 0 to 3 feet is going to have to go through. The pond depth gets over 3 feet, water's going to start coming underneath. But at that point, we allow gravity to retain those pollutants and keep them from being discharged out of the basin, because they're not enough force in the flow to take them up to the skimmer to get flow discharged out. And then we have a water quality basin. One thing to point out here, in some of our other basins, we showed the skimmer perpendicular to the dam. That was for ease of maintenance. In this case, with the filter, you're going to want to kind of keep it pointed into the, meatier part of the pond, just so that it will move around some. You don't want the filter getting stuck on the sides. But we've got all the same information here on the detail. And so if we go back and look at our model when we run it this way, we now have a water quality flow rate of 0.7 CFS, so nearly 3 times what we had before. And we're using a volume of 7,600 cubic feet. So you remember, before we were using over 10,000 cubic feet. Now we're only using 7,600, far less than that 18,000 required. The skimmer is controlling the 2-year storm. So now the flow rate for the 2-year storm going through the skimmer is 0.78 CFS. And what that means is all flow from the 2-year storm and down is getting treated by the filter to that 90% TSS. So we're now treating the little small storm events that before had very little ponding. We're treating our water quality event. And because our skimmer is handling the 2-year storm, all flow storm events 2 years or less are getting fully treated, 100% of the water to that 90% TSS. So we're treating much more of the annual rainfall, and we've decreased the size of our pond. I forgot to highlight those. So here's the comparison of the storage required for the pond with the skimmer versus the traditional pond design. And make it easier, put it in percentages. you're seeing water quality storm, 30% difference in storage required, 2-year 14%, other storms 12%. So, in short, treating more of the annual rainfall, treating it to a higher level of treatment, and reducing your pond size. So win, 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 all around. So one more poll for you. So now that we've gone through idea of skimmers for post-construction, love to get your thoughts on, would you consider it? And again, they're not right for every project. So yeah, looks like those who responded most are saying, yeah, it's either good or maybe. So, you know, um, and usually we have at least one that says no, and that's okay, you know. So I'll go ahead and end that, share those results. So, everybody but one person thinks they may be right. And, 5 of you think, yep, it's a good idea. So that's pretty good. We're not saying that these are the um, best solution for every situation, but for the right situation, I think they can be a really good option. Also, like to point out for retrofits or redevelopment. So for those of you that work on, let's say, a shopping center that was built 40 years ago, and it's got a pond for water quantity, but they didn't design any water quality. It's really hard to go back in and retrofit that pond to meet a first flush volume-based water quality requirement. And so you end up having to do water quality with a catch basin inserts, hydrodynamic chamber, some other MTD device. Those can be extremely expensive and very difficult to maintain. Potential to, if you can uh, put in a skimmer to maintain that 2-year flow rate and then just add a filter, you've got the whole site covered for water quality now. So real quick about our website. We're very proud of our website. We think we've got one of the better ones in our industry. As I mentioned, we have these resources. We've got a webinar. Typically, we keep this to one of the more current, may not need the most current, but one of the last couple of months on demand. So you can go in and watch it. I mentioned our training series. We've kind of broken it down into bite-sized chunks for you to make it easier to find what you're looking for. You can go here and download our engineer spec pack. That's going to be a zip file. It's going to have 3 different folders. It's going to have the Marley float skimmer details, our design tool, test data, any supporting information you need, maintenance requirements, that kind of thing. We have our sediment basin details, and then we have our water quality basin details, design guidance, test data, supporting information there. So if you download that and extract that zip file, it will save it on your computer. It'll organize it for you, make it easy to find what you're looking for. Again, a couple things about our skimmer. It is HDPE. It's UV resistant. We'd say virtually indestructible. We've seen some skimmers go through some pretty rough stuff and be fine. We intended for it to be usable for permanent part of the outlet structure when we invented it. And it's got no moving parts, just has one little piece that pivots. It's got a shielded orifice here. So that's the debris guard. Again, most of the water is going to come under that debris guard. It's going to trap the floatables in the basin. That's going to increase your sediment trapping efficiency. And because we're taking water from below the surface, it's going to continue to work in what I'll call mild frozen conditions. Really, if you're in, I think everybody on here today, depending on where you're from, I think we have a couple in Indiana and Ohio, you may see some frozen conditions that would prevent it from working. But in most cases, it take, probably 3 to 4 inches of ice before it stopped working. Little quick video here. This is our orifice plate. So this just shows you how easy it is to change the orifice size of the skimmer. We also have this little metal piece here. Technical term is nub. That allows you to center the orifice over the outlet hole. Also helps hold that orifice plate in place so it doesn't move around or get come loose while it's flowing. Every one of our models is going to have 3 to 5 flow rates, and they're all been third-party tested. Our skimmer is the way it's designed. It's all the weights, below the center of gravity is low. It's down in the water, so it always stays level, always stays floating. It's always going to self-right. Let's say a goose or beaver or something, climbs on it. It may move around a little bit. Hopefully, nobody's out there in the pond doing that to it. But we have Our 6 and 8 inch, and actually now our 3 and 4 inch all have custom floats. We've designed those to balance the flotation needed, make sure it always stays floating, but doesn't allow the skimmer to sink, in the pond. Because some of these skimmers are pretty heavy, so they need a pretty stout float to make sure they stayed in there. We do have 6 different versions. Our 2 inch goes down to a trickle with our 1/2 inch orifice, only 250 cubic feet per day, or a 0.003 CFS. As you'll see, there's a lot of overlap in sizes with the skimmers. And then point out we have 2 8 inch skimmers. So our standard 8 inch uses a 6 inch pipe to connect the skimmer to the outlet. All the other skimmers use whatever size it is. So a 2 inch uses a 2, 3 inch 3, so on. And then we have our 8 inch with an 8 inch pipe that has even a higher flow rate than our standard 8 inch. So up to 1.8 CFS. That's by far the highest of any 8 inch skimmer on the market. So if you do have a large site that maybe had multiple skimmers needed, you can, use one of our 8 inch 8 inch pipe. So last
So
thing today,
for a 5 acre land or the area, you would recommend the 8 inch orifice or eight
it,
inch.
it depends on the volume you need. So the 8 inch with 8 inch pipe is going to be, if it's in Georgia, you got 1,800 cubic feet per acre, it's probably going to be a 30 or 40 acre site to need that. I'd have to run the math, but it's going to be, again, based on that volume requirement and how fast you want it to drain. So, or post-construction wise, depending on what your post-construction flow rate is, if you're using it with the filter, you can handle a pretty big site and maintain the water quality. So no, we're running right up on 1 o'clock here. So last thing I want to do is just a quick introduction. Digital Sightbox is a relatively new product, just been out in the last year. It's not my product, but I'm helping the folks that invented it get the word out. It is the replacement to the on-site job box. And so it's simply a sign with a QR code that takes you to a website. We've all seen, if we've been in construction for any time, we've seen the problem with paper on job sites, right? It's wet, it's not there, it's not up to date, it's been knocked down, hit the mud, boxes open. My favorite is the occasional wasp nest that's in these things. So, it's antiquated, doesn't work well, and we've all experienced significant issues with it. So it's about time we bring that into the digital world here. And so now you can see all your products in one place, all your projects in one place. You can manage your users. When you set it up, you set up a lat and long, so it automatically does a rain gauge for you. And within your projects, if you need to secure certain folders, so you've got some stuff that needs available to the public, some for project members only, you can secure it with a pin. Again, you've got the rain log. It's going to be there. It'll do just about any type of document. So PDF, docs, Excel files, picture files. You can upload CAD files if you need to. You've got a large amount of space. We haven't had any projects run out of space on it. Cool features, it's got a messaging, and it also has timestamps and dates for people that have logged in and viewed things. So you can go in and say, hey, the contractor looked at this on this date, or inspector looked on this date, and see who's been into the project and looking. One thing I'd like to point out, it is free for municipal users. So if you're city, county, state, and you like, hey, that sounds cool to me, you can go online, go to digitalsightbox.us, and scroll down the page. You're going to see where to sign up for your municipal account. Just set it up, plug in your location, your name, address, name, title, and email. Create your own password. You'll get an email confirmation, and then as sites come on in your area, they will show up in your account automatically. So a lot of places here in the upstate of South Carolina have been using this for a while now, and feedback from inspectors has been it's a huge time saver. Especially after there's been a really big rain event, they can jump in there, check the inspection reports and see what sites have problems and see what sites are looking pretty good. Very affordable. So the basic plan goes up to between 10 and 50 sites is only $150 per site. If you look at just the cost to produce a set of plans, it's much more than that. For premium users that are going over 100 sites, it drops down to $75 a site. We do ask, if you're a non-municipal site, if you're a engineer, developer, contractor, and you're going to go check it out, there's a place to include a sales rep code. When you do that, please include Rymar. That just lets Digital Sightbox know who told you about it. They do compensate us for folks that sign up, so we appreciate it if you'll include that when you do sign up. So that concludes today. I think we hit it right just about on the numbers, 101 here. So really appreciate you attending our Skimmer Sediment Basin Design webinar. Be glad to take any questions. For those that have any, please feel free to unmute. If you need a PDH certificate, please email us at info@rymarwaterworks.com. Lynn Ramsey is our sales director. She will get that PDH certificate out to you right away. And then again, we will have this webinar uploaded on our YouTube channel. So anyone else have any questions today?
Thank you.
All right. I know engineers don't like to talk, so if you do have any or think of something later, please feel free to email us. If you are an MS4 on here today and you have any thoughts on the filter, we'd love to hear them. Or if you're interested in the Digital Sightbox or have more information on that, we'll be doing a webinar on it next month, or maybe, I guess, yeah, we're almost in August. We're doing one on it later in August. That'll go in a lot more detail about it. So be on the lookout for it as well. Thank you for coming, and hope you all have a wonderful day.
Bye.
Bye-bye.